12 wants the value of x. Notice we've got two tangents intersecting, but more importantly, the vertex is outside the circle. That means the angle of x should be half the positive difference of the arcs it intersects, big arc minus small. Well, the big arc is this one, which we don't really know. The small arc is this one, which we know is 132. The thing is, when you have two tangents intersecting, notice the entire circle is contained within this intersection. So the big arc EHG is simply going to be 360 minus 132. Or if I subtract this, 228. So 228 minus 132, big arc minus small arc, half of that. All right. So 228 minus 132 gives us 96. Half of 96 is 48 degrees. Find the value of x number 13. Again, intersection point is outside the circle. Therefore, the angle is half the positive difference of the big arc minus the small arc. 25 is half the difference of the big arc, 83, minus the small arc, which actually happens to be our variable. So this is a situation where our variable is inside the formula. We haven't really had one like this before. But the first thing I would probably do, you could distribute to half through because this is an odd number and this doesn't have a coefficient that's even. I'm just going to double everything right now. 2 times 25 gives me 50. And the reason I doubled this side is because it cancels over here. So 50 is 83 minus x. Bring the 83 over, and negative 33 is negative x. Divide by a negative 1 or multiply by a negative 1. X is 33. And now we get some word problems. It says when a person is farsighted, light rays enter the eye and are focused behind the retina. In the eye shown, light rays converge at point R. So light rays come in. God designed your eye to be essentially like what's called a parabola mathematically, where the light comes in and it goes to the same point no matter where it comes in from. And that's how you're able to see. Now, when we grow older and our eyes don't work as well, it doesn't always focus it to the same spot. And in this case, it's supposed to hit the retina, but it goes behind the retina. It says when a person is farsighted, light rays enter the eye and are focused behind the retina. We want it to be on the retina. It's behind it in a person who's farsighted. But they give us the information that arc PS, and we're going to treat this kind of like a circle here. Arc PS is 60 degrees, while arc QT is 14 degrees. What is the measure of angle PRS? Okay. Well, notice the vertex is outside the circle, so the angle is half the positive difference, or the big arc 60 minus the small arc 14. 60 minus 14 is 46, so half of 46 gives us 23 degrees. Now, 2 of the 6 muscles that control the eye movement are attached to the eyeball and intersect behind the eye. If arc AEB is 225 degrees, what is angle ACB? Okay, so being that this vertex is outside the circle, the angle is half the big arc minus the small arc, of which the big arc they gave us was 225. But what's this small arc, arc AB? Again, notice the entire circle is contained within two tangents intersecting. So I can find arc AB here by taking 360 and subtracting 225 from it. Or get 135. Okay, so 225 minus 135 gives us 90. Half of 90 is 45. So 45 degrees.